Hello everyone, welcome back to my channel codeWithKhan. Let's see today's LeetCode problem 3634. Minimum removals to balance an array. Medium marked. And let's read the question. You are given an integer array nums and an integer k. An array is considered balanced if the value of its maximum element is at most k times of the minimum element. So it means in given an array, if we take I as a minimum element and j as a maximum element, right? This minimum element should be at most k times of the minimum element. That means j should be less than or equals to k times of the I. So you may remove any number of elements from the nums without making it empty. So we can remove any elements in this nums array, right, within this range any number of times, but we should make at least one element will be present in the array. We cannot delete all the elements. Return the minimum number of elements to remove so that remaining array is balanced. So we need to return minimum number of elements to remove so that array is balanced. So we need to try to remove only minimum as possible. Notice an array of size 1 is considered balanced as its maximum minimum elements are equal. So the condition will always true. So what it is saying is, if we have only one element in the array, so its maximum element is also 1, right? J is also 1 and I is also 1. So it will always be holds true, because if let's say k is equals to 2 and j is 1, which is less than or equals to k into 1, right? It will always be true if we have single element in the array. Now let's check the constraints. Nums.length is less than or equal to 10 to the power of 5. That means we cannot go with the n square approach. We should use order of n or order of n log n approach. And nums of I can be 10 to the power of 9. So we need to make sure we use long if we are doing any kind of operations, like we need to multiply it with the k, right? So we will use longs while doing that. Now let's check with an example. So we have 1, 6, 2, 9. So we need to always check with minimum elements and maximum elements, right? So here anywhere they didn't mention of anything about the ordering, right? Ordering of elements. So what we can do is we can simply sort the array, right? We can simply sort the array. So we can easily find maximum element and minimum element. So every case, right? Either we move to the right direction or either we move left side. So we'll always be make sure that we are traversing to the left side, we will find the minimum elements. If we traverse to the right side, we can know that we are going to see the maximum elements. So now what we'll do is to check, like we need to pick maximum element and minimum element, right? And we can compare it with the, so j should be less than or equals to k into I. So what we'll do is, so we will use these, since we are handling with two indexes, we use two pointers approach. And we'll try to create a window, right? A window with these two pointers, right? First, let's check. Let's see. We are at same position. I and j at the same position, right? Let's check if this satisfies the condition or not, right? Which is 1 is less than or equals to, and k is 3, which is 3 into 1. So 1 is less than or is equals to 3. So this is satisfies this condition. And it is we already know that if window has only one element, that is always balanced array. So we will update the answer. We'll keep answer as default one, because if array contains one element, then we will definitely going to have answer as a 1. So we'll update answer to 1. Now since we have one in the answer, so what we'll do is we try to update our window, right? We'll try to add some elements into our window. Now current window size is 1 only, so we'll move further. So we'll update the j. Now j comes here and window becomes this. Now window will hold 1 and 2 both. Our window updated. Now let's check this condition again, which is 2 into, now j is 2. Now 2 is less than or equals to 3 into 1. 2 is less than or is equals to 3. This is false condition, right? 2 is, sorry, this is, let's see, the condition is 2 is less than or equals to 3 into 1, which is 2 is less than or equals to 3. This condition is also true. That means this window is also valid window and this is balanced window, right? So now we'll update the answer with maximum window size, which is 2. Now window size becomes 2. Now we'll update the j. We'll move further. We'll try to increase the window size. So this is a balanced window. Now let's more greedy because we need to find the maximum elements, because if we find maximum balanced window, then only we can remove the minimum elements, right? So we need to find minimum removals. To find minimum removals, we need to find maximum balanced array, right? We need to find maximum balanced array so we can remove the minimum elements. So till now we found this balanced array. Now we'll try to extend. We need to add one more element to this window. We'll check if this is balanced or not. So now we come to j. Now let's check this condition again. Is j is less than or equals to our k into I? So j is 6, which is less than or equals to 3 into 1, which is 6 is less than or equal to 3. No, this is false. So what we'll do is, now this window is not a valid window, right? So we cannot move further, right? This 6. So if we add 6 itself, it is not balanced. Then how we can add this one? So what we'll do is, we'll decrease the window's size. We'll shrink the window, right? We'll remove this one from this window, right? What we'll do? We'll increase the I now. We'll increase the I. Now window is I to j, which is 2 to 6. Now let's check this one. Now it is 6 is less than or equals to 3 into 2. 6 is less than or equals to 6. This is also a valid window. Now this also becomes a valid window. So we'll update the answer. It is already 2 and this window size is also 2. We'll keep it as 2 only. So when we found a valid window, what we'll do? We'll try to be more greedy and we'll try to add one more element to this window. Now we'll update increase the j and we'll include this element into our window. Now let's check this condition again. Now 9 is less than or equals to 3 into I is 2 only. Is 9 is less than or equals to 3 into 6, which is 6. So is this a valid condition? No, this is not valid. So this window is not valid. So what we'll do? When window is not valid, what we'll do? We'll shrink the window, right? We'll shrink the window. So we will update I. Now I became 3. Right, sorry, 0, 1, 2. Now I became 1. Now let's check this condition again, right? 9 is less than or equals to 3 into, we're at 6. Now 9 is less than or equals to 3 into 6, which is 18. Now this is also a valid condition and this is also a valid window. So now we will update the answer. So answer is already 2 and we also have 2. So max of 2 comma 2 is only 2. And j, we went to out of bounds. So we'll just return the max answer we have found till now. So what the logic we have used is, we are used the sliding window approach with 2 pointers. So we use a sliding window approach using these 2 pointers. What we did is, so we are choosing the minimum window and we are going greedy by adding the more elements to the window, and we are checking if it satisfies this condition or not. If this satisfies, we'll be more greedy and we'll add more elements to that window. Otherwise, what we are doing, if this window is not valid, and we'll just shrink the window, right? We'll shrink the window. If the window is valid, we'll be greedy and adding more elements to it. If the window is not valid, then we'll be shrinking the window. So in any sliding window approaches, so we need to follow the same pattern, right? We need to follow the same pattern. So we need to be greedy, right, to find the maximum window sizes or maximum values, right? So what we'll do is, so we will be having one window first, and then we'll be greedy and we'll increase the window size, and if the window is not valid, we'll decrease the window size. So now we found the maximum window balanced maximum window size, which is 2. We need to find the in the question they have asked to find the minimum number of elements to remove, right? We found the balanced one, right, which is 2. So we need to how many so these two are balanced array, right? This window is a balanced array. So we need to remove this one and this one. So how we can find that? We'll just remove this window from the length, which is 2. 4 minus 2 is 2, right? We'll return this answer. Okay, so I hope you understand this. And let's see the time complexity. So time complexity is, so we sorted the array which is order of n log n, then we iterated the array one time, so order of n. So the maximum n is order of n log n. What is the space complexity? So space complexity, we have not used anything except that storing the answer, so it will be order of 1. Now let's code it. We will take int n to store nums dot length, and then we will use int answer is equals to 1, since like if we have one element in the array, then it is going to be the answer. So now let's sort the arrays dot sort nums, and then let's take int I is equals to 0 as a left index, and then we'll traverse the array. Int j is equals to 0, j should be less than n, and then j plus plus. Now what we need to do is, we need to find the a balanced window, right? We need to find the balanced window. So if it is not balanced, if it is balanced, then see, if it is not balanced, right, so then what we need to do is, so when it is balanced, if nums of j is less than or equals to k times of nums of I, right? If this condition is true, then that is balanced. If this is not true, that means that is not balanced. So what we'll do is, we'll string the array first. We'll string the array, right, when nums of j is greater than k times of nums of I. So in this scenario, what we'll do is, we'll string the window size, then it will become the balanced array. Now let's deal with the, so nums of I can be, right, they can be long, so we'll use long here. Nums of I can be 10 to the power of 9, right, so we'll use long, we'll convert them to long. So now here, so with this while condition, so we are making sure that this window is, the window I to j is a balanced window. So now what we'll do is, we'll update the answer is equals to math dot max of answer, comma. So now how can we find the window size? So let's take j minus I plus 1. So these are the indexes, so we'll add 1 to find the its window size. So now once we have the answer, so we know the maximum window size, what we'll do is, we'll return length minus the window size. Now let's run the code. Yeah, it is accepted. Let's submit it. Yeah, it is accepted. Please do like, share and subscribe. Thank you guys. Happy coding. Bye.